All these big things on my ears. Yeah.
All right. So there's our 10-second intro. And because of my non-stellar communication, we have Craig did not have a chance to get the intro together this time. So
Right. That's okay.
um, that's okay. So we're here talking about church hurdles to believing in God. And a lot of these that we've been doing have pointed toward evidence for God's existence, or at least evidence for an intelligent designer of the
Right.
universe. And we'll continue that on. Today's show is the well. What is today's show, Susie? I'm going to give that one to you because I just choked on that.
The you mean the not the safe zone?
The balance of the universe and living in the safe zone.
Yeah.
Yeah, that's it. There it is. And so,
But we want to make sure that everybody understands that we do want to practice safe church hurdling. So we're in the safe zone.
also, we welcome your comments and questions and thoughts. And Susie?
Yeah, anybody's comments and questions and thoughts, honestly, at this point. I'm working on a sneeze, so I'm just letting you know that fair warning. So everybody's going to get the. See?
Score!
Okay.
Well, apparently,
I'm
there are some
allergic to
allergens
hurdles.
in our safe zone.
Yeah, well, I think it's sawdust. But so one of I know it's been a couple of weeks, so probably both of us are maybe a little bit rusty. Some of us more than others. That would be me. But
Sawdusty.
yeah, but I think that the last time when we were talking about, just for folks that maybe don't recall, we were talking about, how can you explain the things that we see around us, and the beginning of the universe and all of these things, and and of course, our disclaimer is that, of course, we're just here to discuss this stuff. We're not really here to evangelize or convert or anything. It's literally just stuff to talk about, and we would love it for anybody else, who, either if it's a hurdle for you, or if it's maybe it was a hurdle in the past and you found a way around it, or it's just your belief. I mean, we'd like to hear your comments and questions. So I found something really, really interesting, and I know this is not probably in your outline, but
Yeah,
I gotta
that's all
tell you
right.
about
What
it.
you got?
Okay. So, you know how a couple weeks ago, well, a couple weeks ago, what am I talking about? I've been bugging you with this stuff for what, years? So the we were talking about in the beginning, and some of the things that we read about, and some of the things that are in the Bible, and then we were talking about, like, the Big Bang Theory and all this stuff. And then of course that poses the question, well, where did God come from? If God caused the Big Bang, then where was God, right? So an interesting thing I came across, and although this is in the Bible, but it is also in many, many, many various religions and just general knowledge, okay, is Proverbs. And in Proverbs 8, the most amazing thing, I want to say it's verse 22. And I could pull it up on my phone now that I think about it. But it is so cool because it talks about wisdom. And it says, before the earth was ever created, there was wisdom. That I was there. It says, as wisdom speaking in first person, says, I was there before the world was created. I was there when you were, the earth was made. I was all of these things. And I thought, that is really cool. Again, it's one of those things that nobody ever, in all of my years of asking and hoping to find some kind of an answer or some kind of explanation, that never came up. And I just thought that was really cool. I just came across that, and then today I just happened across it again when I just happened to open it, and I was like, that is just super cool, because there's no need really for that to even be brought up. I mean, it could just be like, I've been here since the earth was made, or but it gives the impression, right, that before the heavens and the earth and the universe, or any of the things that we know about, there was already something, wisdom, you know. Although some people would say, well, it's not very wise to believe that, and that's okay too. But I just thought it was a really interesting. If you read Genesis, like the very beginning, literally in the beginning, you read that and then you flip over to Proverbs, it's amazing. It really,
Yeah.
I thought that was really cool.
And if you think about wisdom, that really is a non-physical thing. Like it's an
Yeah,
element
right.
of learning. It's there's knowledge, there's ideas, there's even analysis of different ideas involved in that wisdom. And so it doesn't have to be confined to the physical world. It can pre-exist it easily.
I think it's really neat because it implies that something can exist without a physical um, presence, like, which is hard for
Right.
it's hard for a person like me, because it's like if I can't see it,
Blows
it's
our
not there,
minds.
right? Because
Yeah.
if I don't see it, it's not there. Kind of like that pie I just ate, it's not there. So
Bacteria.
right? No, there's no bacteria. I don't have to clean.
All
I
right.
don't see any bacteria. All right.
So, all right. What we want to talk about is the balance of the universe.
Right.
And so, what we're going to talk about in this first part of the show, we'll see how long I go with it, but that is the anthropic principle. The who? That's where that's where Susie says,
question
"What
mark?
are you talking?" We don't talk like that on the show, Matt. Oh, sorry.
Oh, sorry.
So the anthropic principle comes from the anthropos, which is man. And the anthropic principle ends up being all the seemingly unrelated, arbitrary constants in physics have one strange thing in common. These are precisely the values you need if you want to have a universe capable of producing life.
Right. Because I don't know if you know me very well, but I don't follow a recipe for anything. And I can just tell the one or possible one viewer that we have that if you don't follow the recipe, the cookies really don't turn out like you had hoped. But sometimes I just think like I know better. I'm like, oh, well, I'll just put a little more of this in there. That'll make it even better. And then they're not. So
what are those fast videos, the time-lapse videos for cooking stuff you always see?
Yeah. Is it Tasty or something like that?
Yeah. Tasty.
Yeah.
My kids even got Jessica a Tasty apron, and it doesn't turn out the same if you don't follow. Doesn't look like it does on Tasty.
I don't like recipes, so that's the problem. That's why I can't crochet with a pattern or sew with a pattern. I just wing it, and that's how I like to do it. And I do the same thing with cooking. If I ever make something and it's really good, Roger will be like, "This is awesome. You should make this again." And I'll be like, "I wish I could."
Yeah.
So anyway, sorry about that. Okay, back to you, Matt.
All right. That is pretty much most of our introduction, but we're also going to say this. As recently as 25 years ago, a reasonable person weighing the purely scientific evidence on the issue would likely have come down on the side of skepticism. That is no longer the case. Today, the concrete data point strongly in the direction of the God hypothesis. It is the simplest and most obvious solution to the anthropic puzzle. And this is, make sure I get the right, this is a scientist named Glenn.
Oh, hi, Glenn. Scientist Glenn. Could you throw that at me in layman's terms?
Sure.
Yeah.
Let me back up and see actually who Mr. Glenn is here. Here we go. Patrick.
Maybe he's like a pop star where he just uses one name.
Well, Patrick Glenn, a former arms control negotiator for the Reagan administration and currently the associate director of the George Washington University Institute for Communitarian Policy Studies in D.C.
That sounds almost made up. Sorry, Glenn.
That's a lot. Okay, so that principle again was basically he's saying that if you're looking at the purely scientific evidence, it really falls on the side that there is an intelligent design. It falls on the side that there's a personal intelligent designer. And so favoring the God hypothesis.
Right.
Yeah.
Oh goodness,
So,
sorry about the yawn. Okay, so
uh,
uh, one of the things that I think people struggle with is when we talk about, you know, things like that. Of course, everybody has their own preconceived opinions about some of this, and I don't know what Mr. Glenn's are, um, but I think that if you look at it objectively, that it when you I mean I understand, like, we can't 100% explain everything anyway, right? None of us can.
sure.
But I think that if you're an open-minded person, that even if you don't even have a belief system at this time, it is very hard. It was hard for me even to imagine that these things just do what they do the way they do it. And um, I think too, I think this is something that we talked about last time. When you talk about things that just kind of happen, you would think we'd have a lot of one thing, maybe a couple things, but we don't. We have such an amazing amount of different types of critters and people and plants and seashells. I mean, did we need more than one kind? Apparently, I don't know. But it's kind of interesting. It's like, why wasn't there just one fish? Why wasn't there just,
Yeah.
one kind of cat? I just, I think it's kind of, when people talk about the things that need to happen, like you talk about being in the safe zone, right? So I mean, there's a lot of additional factors that go into that, just aside from being able to sustain life. There's diversity in it, that is really difficult as well to explain or to understand.
Right.
I mean, it's just like, you have red hair and I have brown hair if I color it. And, I have green eyes and I don't know what color your eyes are, but my daughter and I, we were talking about this the other day. I'm like, look at my eyes. They're so cool. Because there's like 14 colors in my iris. It's the weirdest,
Yeah.
there's green, there's blue, there's yellow, there's hazel, it's just various shades of all kinds of stuff. But something, the iris color isn't, I don't think, necessary for sight. It's just what you get.
Right.
And
Yeah.
so why not just have the one, you know? But yet, for whatever reason, there's all this diversity.
You mentioned Patrick Glenn's background. Basically, he was a confirmed atheist by the time he received his doctorate from Harvard in the 1970s.
Mhm.
And then, as he goes on to delve deeper into, where did the cosmos actually come from, he says, gradually, I realized that in 20 years since I opted for philosophical atheism, a vast systematic literature had emerged that not only cast deep doubt on, but also from any reasonable perspective, effectively refuted my atheistic outlook. Today, it seems to me there is no good reason for an intelligent person to embrace the illusion of atheism or agnosticism to make the same intellectual mistakes I made. So he's like, I had reasoning, but it just wasn't lined up well. And
Mhm.
I talked to a young man last week who is trying to figure out what he believes, and he's trying to, um, and I think really he's just in a kind of suspended type of state,
Mhm.
um, just kind of in a unconvinced. He's in the unconvinced category.
Okay. So did you give him my number or tell him to hurdle with us?
well, he did take a picture of this great book that we're looking
Mhm.
through, The Case for a
Awesome.
Creator
Yep.
by, there it is, mirror image, Lee
Trouble.
Strobel. Yeah. And basically, I would just encourage everyone the same thing I encouraged him. I'm not telling you to get baptized this week.
Right.
That's not where we're going. Just
No.
consider the facts and find out what the answer is,
Mhm.
because there is an answer if you go deep enough. All right. So one of the first thing that Lee covers in his book, after kind of introducing us, is the prima facie evidence. And I had to look that up. You'll be glad to know. I don't know what that
Thank you.
means,
Mhm.
but it means literal translation from the Latin, at first face. So your first impression.
Okay.
Love at first sight. What is that first impression? How does it come across? Well, it comes across as there's really intricate design. That's what you talked about just now. Um, next, we're gonna talk about a biodome on Mars. So
Okay.
there's an example that's used by Robin Collins, and he, of course, like a lot of these guys, is outstanding in his field. Has multiple papers and books published. Let's see here. After serving as a postdoctoral fellow at Northwestern University, Collins spent the last decade doing research, writing, teaching at Messiah College, where he is currently an associate professor of philosophy. So, these guys are not like me. They actually have studied this for their entire lives, are recognized in the field.
Okay.
So, let's see here. He says, I like to use the analogy of astronauts landing on Mars and finding an enclosed biosphere, sort of like the dome structure that was built in Arizona a few years ago. At the control panel, they find that all the dials for its environment are set just right for life. The oxygen ratio is perfect. The temperature is 70 degrees. The humidity is 50%. There's a system for replenishing the air. There are systems for producing food, generating energy, and disposing of wastes. Each dial has a huge range of possible settings, and you can see if you were to adjust one or more of them just a little bit, the environment would go out of whack and life would be impossible. So if we found something like that on Mars, what would the conclusion be?
But it's not a biodome, or it is?
It is a biodome.
Well, obviously, we would assume Martians put it there.
Right.
So
some highly intelligent Martians.
Right. Or Elon Musk,
right.
took like a joyride one day.
He might be a Martian. I'm not sure.
He might be, yeah. I don't know. But if there was ever someone that was going to do that, it's probably him.
Right. With his super intelligence.
Right.
So would you conclude it got there by accident?
Well, no. Of course, I'm gonna, me, I have to do it. I have to.
Let's do it.
It's easy to figure that out because it's all with man-made items, right? It's a structure. It's not formed with, now if somehow rocks stacked themselves upon one another and sealed themselves, and I don't know, whatever. I don't know what rocks are really capable of. But anyhow, that all being said, it's so much easier so when we use examples like that,
right.
It's harder because we're literally talking about man-made things. I can give you something maybe a little less. This isn't a biodome in Mars, but a concept similar. Since you won't come to the cabin, I'm just going to tell you everything that's out there. So on the road to the cabin, it's an old area. It had not until this year been surveyed since the Louisiana Purchase. Okay,
wow.
So yeah, it's like rugged. So and there's an old logging road. A long time ago, 1900s, so 120 years ago or so, there was a copper and mining and lumber company near that area because of the Jacks Fork River. So they used the river to send the logs down and stuff. So it doesn't surprise me that maybe there would have been settlements, but where our cabin is about a couple miles as the crow flies from the river. Okay. But as you wind down this old logging road that when we bought the property was literally just a place in the woods that didn't have trees that they had cut out so you could drive, that's all it was. When you're driving through there, one of the first things I noticed was just off the road was just this vast amount of just yucca plants in the middle of the woods that formed a rectangle. Okay. So yucca plants shaped like a rectangle with a big opening in the middle and yucca plants surrounding it, that left me to conclude a couple of things. That probably there was something in that rectangle that kept yucca plants from being planted there. And then later in the spring, early in the spring rather, there are always daffodils, also not typically known to be wild, in the middle of the woods. And then about this time of year, irises. So what does that tell me? Well, that tells me that some little old lady who was really fond of flowers and yucca plants had a little house there. There was a little
Right.
homestead of some kind there at some point in the past. Now I can't see that homestead; it's gone. But I can see evidence that tells me that somebody had to have planted those. Somebody had to have done that. Now, I can't see the structure, right? I can't see the biodome. I can't see it. But if I saw it there, then obviously I would know somebody built it. But even without having the structure there, I can know that in the past there was somebody there.
Right.
And so when we use when we use examples where we're talking about a man-made structure, then it's easy to use that argument, right?
Right.
Because I mean, clearly somebody made it. However, all it's going to take is for them to truly discover, whether it's Mars or wherever, to find water and uh, that's the thing that I find the most interesting is that we have water and we have the land, but we have salt water, we have fresh water. We have way more salt water than fresh water, which is interesting. I always kind of assumed there'd be more fresh water on account of that needing water to live and all. But those are the things that are going to be able to help. A biodome with water in it doesn't surprise us, right? Because we had expected if somebody had the gumption to build a biodome, that Elon would obviously put water in it, right?
Right.
Yeah. I
So
hope he
what we're
gets
going to do
this and he
is
starts building a biodome. That's what I'm hoping.
he needs to. That would be fun. So what we're going to do is compare the Earth and actually the whole universe to a biodome. And we're going to see that the settings are exactly just right, even down to an infinitesimal amount of inflexibility. For instance, the physicist Heinz Oberhummer, sure
Did
that's
you
not
just
how he
say?
pronounces it.
Did you say Oberhomer?
Oberhummer.
Okay, I like it. So we're just going to call him Homer.
I feel like I got Heinz closer. And his colleagues show that just a 1% change in the strong nuclear force would have a 30 to 1,000-fold impact on the production of oxygen and carbon in stars. Since stars provide the carbon and oxygen needed for life on planets, if you throw that off balance, conditions in the universe would be much less optimal for the existence of life. All right.
Okay.
So just and what we're going to be talking about a lot is constants.
Okay.
What we somebody has helped me, Oppenheimer. Thank you, Craig.
Oppenheimer, you couldn't get that. That was easy. There was Oppenheimer Sports in Springfield.
It even has a
I'm
B
embarrassed
instead
for.
of a P. I don't
That's
know.
crazy.
So these constants then would be the rate at which carbon converts to, or the rate at which, we'll get to it. One element converts to another element, etc.
Okay.
So these constants, they're these. It's like the speed of light,
Okay.
uh, the rate of gravity, and this kind of thing. The pull of electromagnetism. So these are called constants in physics, and they're always the same.
Okay.
And so these are some of the things that are very fine tuned. These are the dials on the control board in the biodome.
Okay.
So he says, let's talk about gravity. Imagine a ruler or one of those old-fashioned linear radio dials that goes all the way across the universe. That's a long ruler.
Seems like it. Yeah.
It would be broken down into 1-inch increments, which means there would be billions upon billions upon billions of inches. The entire dial represents the range of force strengths in nature, with gravity being the weakest force and the strong nuclear force that binds protons and neutrons together and the nuclei being the strongest. A whopping 10,000 billion, 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 that was 4 billions, times stronger than gravity. So in an atom, the nuclear force allows those
Okay.
protons and neutrons not to just kind of go off into thin air, not to just gravitate away, degravitate away. So that's what we're talking about with a strong nuclear force. It's holding the atoms together.
Okay.
All right. He says the range of possible settings for the force of gravity can plausibly be taken to be at least as large as the total range of force strengths. Now, let's imagine that you want to move the dial from where it's currently set, even if you were to move it by only 1 inch. And this is this dial that's so huge it expands the entire universe.
Okay.
And you just move that 1 inch. So that's going to be a very, very tiny movement.
Okay.
He says,
The 1 inch on this ruler that expands the universe.
yes.
Wow. Because I can be an inch off on a 12-inch piece of board. So
Right?
and it does make a big difference.
Okay. He says, so just that tiny amount. The impact on life in the universe would be catastrophic. 1 inch compared to the whole universe, I asked. This is Lee,
Okay.
interviewing him.
Right.
And he said, what kind of impact could that have? He said, that small adjustment of the dial would increase gravity by 1 billion fold. So Lee's like, well, that sounds like a lot, right?
Increase
That's like
gravity?
1 billion times 1 billion.
That sounds like a lot.
He said, actually, it's not. Relative to the entire radio dial, that is the total range of force strengths in nature, it's extraordinarily small. Just 1 part in 10,000 billion. Those 3 billions. I nearly missed one.
Oh, man. Okay. You're going to have to dumb that down for me.
Well, we're going to get to the effects here in a minute.
Oh,
he says,
okay.
Animals anywhere near the size of human beings would be crushed. As astrophysicist Martin Rees says, in an imaginary strong gravity world, even insects would need thick legs to support them, and no animals could get much larger. In fact, a planet with a gravitational pull of 1,000 times that of Earth would have a diameter of only 40 feet. So because the gravitational force is much larger, a smaller amount of mass has more pull.
Gotcha. Okay.
And
I kind of remember that.
To have the right amount of gravity, that planet would be 40 feet across. Not much of an environment.
Be like, I would walk the world for you. You could literally do it.
Yeah, it'd be a couple of steps.
Right. Wow.
Right.
Okay.
And you can imagine how thin the atmosphere would be and so on. Just standing up, you'd be, I don't know, probably in the upper atmosphere or something. All right. Besides stars with lifetimes of more than 1 billion years compared to 10 billion years for our sun couldn't exist if you increase gravity by just 3,000 times. And so he goes on to say there's just a tiny narrow of range for life to exist.
Well, I mean, think about this. Even on the Earth, right? You climb a mountain, you get very far up there. It's hard to breathe.
Yep.
Now, I just read that. I don't want anybody to think I've been out there climbing mountains. Hasn't happened. But we do know that that's true, right? And so that's something that we can personally, physically experience. I assume that people acclimate to that at some point, but I know that it's hard for people that are not conditioned to do well in things like that. I mean,
and at some point, it just becomes impossible to acclimate.
Sure. Well, I mean, let's just look at temperatures, right? We know that it doesn't take much of a change in temperature degree, right, or humidity to make a huge difference in our survivability. In the if you're outdoors and you don't have shelter, you'll die of heat exhaustion sometimes in a very short amount of time. Even if you're kind of planned for it. I mean, I don't know if you recall last year there was that family, and it was just like a mom and a dad and their little, I think she was 2, and their dog, and they went on a hike. And these people, they succumbed to the heat in just some hours. And unfortunately, it just they just underestimated. I think the heat that day got up to like 110. And to me, it's like, what's 100, 110? They're both hot, but obviously one was much more catastrophic. And it's the same thing when it comes. I mean, look at water. 1 degree makes all the difference.
Yeah.
So
Yeah.
sorry, a
Between
little
freezing
tangent.
and not, or yeah.
Yeah.
So it demonstrates that really tiny band of habitability. There's just a tiny difference. It makes all the difference between
Right. Yeah.
us being able to live or not.
Yeah.
So let's see here, and that's just this gravity is that's just one parameter that we have for life. He says one expert said there are more than 30 separate physical or cosmological parameters that require precise calibration in order to produce a life-sustaining universe. I think this gets back to what you said about a biosphere would obviously be man-made, and so it's
Hmm.
easy to conclude, well, yeah, we know somebody designed that, somebody built it and put it there.
Hmm.
But when we look at the actual requirements for life in our universe, what we find is the requirement for design is maybe even more stringent. Like it's even harder to do. We tend to take for granted things that we're familiar with. I walk out in the backyard, there are oak trees, grass, none of that surprises me.
Right.
And so I think we just think, oh, well, hey, if somebody says it could have evolved, maybe it could have.
Hmm.
I don't see God in the grass. I don't see God in the trees.
Hmm.
But when you begin to study the minute detail of all of these things, then what you find is it does begin to look miraculous.
Yeah.
Just that the earth sustains
I
itself.
mean, again, it goes back to why do we have all the various varieties of trees? I mean, why what one tree was just as good, right? I mean, you know what I'm saying? I've always found that to be kind of interesting. Why aren't there just palm trees or just oak trees or just? But they all have their own temperate environments that they grow in
Right.
and they thrive in. It's the same
Right.
thing. Just like for people, that's one of the reasons that there's not a lot of cruises to Antarctica to hang out for the vacation times and stuff like that. A little cold there. Don't get a lot of beach time. So it's the same kind of thing. And I think that it's um, although I don't have the answers to those things obviously, but for me that was a big deal. Like just being able to say I don't have a problem with evolution in the sense of obviously things. I mean, even human beings, we can see that. People
Right.
have evolved. I guarantee you, 100 years from now, they're going to be like, I don't know what happened, but humans started getting really fat, and we don't know what caused that. Well, it's going to be pretty easy. It's going to be like, well, according to Susie's diary, it looks like it was Little Debbie cakes and potentially not following the recipe on a cookie. So but the thing is that I I find it really interesting when we when we if it's something that we can see, touch, any of our senses can relate to, um, we we automatically can put all those things together. It's the things that we can't see, right? So we can't see, for example, down into the minute details of all the things that produce a tree, a blade of grass. Although grass just seems to find its way wherever you want it there or not. Um, so it is resilient. But I think that, for example, I mean, you've got some trees are hardwood, some trees are not, some trees are fruit trees, some trees are, some trees are just trees. I don't know what they're good for. These sweet gum trees, they're not good for nothing. They're just not going up my yard. But
Yeah.
I don't, nobody's going, boy, I sure wish I could build my house out of sweet gum. Nobody ever says that. That is a fact. And
And
but I do think that is something that we take that for granted, right? Because I mean, from the very moment that we're born, they're like, oh, there's the trees, there's the grass, there's the whatever, and it all. Sometimes I wonder about for folks who have some kind of issue with maybe a vision issue or hearing issue where they don't have all of the five senses that maybe they see. I use the term see, but maybe they're view of the world or their take on the world is different from ours because obviously they're having to um, understand their environment without that luxury of all five senses.
I was just talking about that a little bit before the show on a phone call today. My mom is deaf. She was born, she couldn't hear. Her hearing in her left ear is totally gone. Her hearing in her right ear is only possible through like the most advanced hearing aid. And I was talking with my brother-in-law who married my sister, and of course this is all new for him, and he's gotten to experience it over the last decade or so. And he's just like, wow, really makes you appreciate what you have. And that's kind of how life is. Life is everywhere. We can't keep the crabgrass out of the yard, dandelions. But as a matter of fact, really, it's very difficult to produce the conditions that make life work. Let's see. We're going to talk about the cosmological constant. And so, just in case that's Greek to everybody else, that is the density of energy in empty space. The density of energy, like in outer space, in empty space.
Okay.
So there's an energy there, just like sunlight going through the air, radio waves, etc. There's energy there, and there's a certain constant. There's a certain amount of it in the universe.
Okay.
Nobel-winning physicist Steven Weinberg, an avowed atheist, has expressed amazement at the way the cosmological constant, the energy density of empty space, is remarkably well adjusted in our favor. I can see I'm boring Susie.
No, it's not you. It's me. It really is. So hang on. The last sentence that you said, read me the last half of that, because
So that constant, the amount of that energy in empty space, is remarkably well adjusted for life in our favor as humans, as living beings. The constant, which is part of Einstein's equation for general relativity, could have had any value, positive or negative, but from the first principles, Mr. Weinberg thought, he says, one would guess that this constant should be very large. Okay. Fortunately, he added, it isn't.
Oh, good.
If large and positive, the cosmological constant would act as a repulsive force that increases with distance, a force that would prevent matter from clumping together in the early universe, the process that was the first step in forming galaxies and stars and planets and people. If large and negative, the cosmological constant would act as an attractive force with distance, a force that would almost immediately reverse the expansion of the universe and cause it to recollapse.
Okay.
So, again, this is just a constant, a specific number, an amount of energy in empty space that has to be just right so things don't blow apart or fall in on themselves.
Right, which is not what we want.
We're talking about in an atom. We're talking about even planets in a solar system or galaxies in the universe. Okay. Let's see here. He says, when I asked Collins, which is the guy who Lee is interviewing in this part of the book, about this, he told me that the unexpected, counterintuitive, stunningly precise setting of the cosmological constant is widely regarded as the single greatest problem facing physics and cosmology today. How precise is it? I asked. Lee tells us.
All right.
So that is the question. Just like in that biosphere, if you have metal straps or whatever in between the glass, how precisely do those rivets have to be centered and to correctly hold the force of the
just like manufacturing an airplane. You don't want to be like, I'll just throw these rivets wherever it feels good. That's how I build things. That doesn't
work.
That's why I don't build airplanes.
All right. Collins rolled his eyes. Well, there's no way we can really comprehend it, he said. The fine-tuning has conservatively been estimated to be at least 1 part in 100 million billion 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 billion. That would be a 10 followed by 53 zeros. That's inconceivably precise. When I learned math, I was told
my
teacher told me,
doesn't go that high.
I know, right? My teacher told me, usually in the real world, 2 decimal places is fine, 3 or 4 if you have to be really precise. This is
Right.
53 zeros
Yeah.
after the decimal place. And so
That's
in
just
other
showing
words,
off.
well, maybe it is. All right, let's see here. So Lee says, "Can you give me an illustration?" I think we'd all like a way to wrap our minds around that a little better.
Yeah.
It says, "Put it this way: let's say you were out in space and you were going to throw a dart at random toward the Earth. It would be like successfully hitting a bullseye. That's 1/trillionth of a trillionth of an inch in diameter. So not a
That sounds
16th, not a
small.
32nd, a
Right.
trillionth of a trillionth."
Also not on my tape measure.
Right. And so he says, that's less than the size of one solitary atom.
Oh, wow.
So we're throwing this dart at the dartboard at less than one atom's size of bullseye. I don't even
Right.
do well with a normal dartboard, so.
I hear you, brother.
Okay. Obviously that's just mind blowing. I know even the most precise people, they don't get things to that precise of math. This is something that we as humans struggle to discover, and there's no way we could figure it out on our own. You know what I
Yeah.
mean?
Right.
So this is another one of those things, another one of those dials in the biodome. You got anything before we go to the mass difference between protons and neutrons, Susie?
Ooh, protons and neutrons. Well, no, not really. I mean, I think that again, we know that everything is perfectly tuned for us. And now,
Yeah.
you know, areas that live in less than desirable environment, such as areas with a lot of pollution and smog, things like that. People have respiratory issues that stem from that. We also know that, um, if if a volcano, right, if a volcano erupts and it blocks out the sun for very long or causes ash or whatever, there's long-term effects from things like that. And we know from looking through the geological records and everything else, we can see some of that history and what impact it had on humans and other life. So I think it's really interesting when people, um, again, it's like you don't have to necessarily believe uh, what we're what we believe, but you can certainly entertain the idea. It's the same thing. Like I would have just been, like whatever, sure, biodomes on Mars, okay, sure, whatever. And I would have been the first person to say, yeah, well, if it's got steel pipes and glass and stuff, probably going to assume that it didn't just assemble itself. And that is if you think of the Earth, though, as a biodome, only our biodome is so perfect that we don't need metal struts or glass or rivets.
Yeah.
Uh, but it is, again, it goes back to trying to explain it, and it's always been here, right? So when we're, like I said, when we're born, it's just here. It's
Yeah.
just, there's no real like, um, like you're not born and then you go through like a tutorial of, of Earth and life and things like that. It just is. And so that one is always harder. It was always harder for me. It was just as easy for me for the longest time to be like, I don't know. I don't know how it got here. I don't really care how it got here. It's just here. That's cool.
Right.
But
Right.
then I'll be honest, as I get older, and maybe that's just my mortality staring me in the face. But I think, that's really fascinating that that's like that. Just like rainbows and prisms but again, I think Lee says this in the book. Once a designer has a model that works, they just continue to use that same model just because uh, most mammals most mammals have four appendages, arms and legs. Then does not isn't because they all evolved necessarily from the first whatever, the first four-legged thing. somehow they came into other four-legged things. I don't really understand that part, but anyway, but what happens is if there was an intelligent designer and a set of legs and a set of arms seem to be working pretty good, you keep that same design. There may be modifications to it. I think we've talked about this before in the context of a car. You know, cars. I mean, look at the horse and wagon. Look at chariots. Chariots were two wheels. Later on, they were like, you know what? We need to haul some stuff around. And so, somebody's like, well, what if we made a bigger box and we put bigger wheels on it, more wheels? And everybody's like, more wheels. That sounds great. So they do that. But then when it came time to make a car, everybody already kind of figured out the rudimentaries of it, right? It's like, okay, it's ideal to have driving wheels that can turn and then have basically follow wheels. And then later it's like, it'd be really great, 4-wheel drive. Yeah. So then, but it didn't change the fact that there were always 4 wheels,
Right.
So I think that was one of the things that Lee, when he mentioned that in that book, and I don't remember which chapter it's in, but I do remember that kind of resonating with me. It's like, that would make sense to me. If I knew something worked, I would
Right.
continue to use that model. I mean, if the heart, lung, brain thing was working, why would you make it different in every one of them? That doesn't need to be different in every one of them. Most mammals, I mean, I don't know of any off the top of my head that don't per se, but, have eyes, but, like bats, they're more of a sonar type, they're more into like, pew, whatever they do. I don't know. Yeah, that's not scientific, but but again, if you just look around you, the general consensus, right, is a very similar layout. We just might have some different cosmetic features. Some of
Right.
us are built like a Jeep, and some of us are built like a Corvette. And I would
There
be
you
in the
go.
Jeep category.
Well, so he says there's a difference in the mass between neutrons and protons. If you increase the mass of the neutron by about 1 part in 700, the nuclear fission in stars would stop. And that's a bad thing because then the stars go dark and there's
Right.
no more light, there's no more heat, there's no more energy for us.
Right. Because I often forget that the sun is a star, for those of you who are just new to the universe.
Right?
Yeah, I forget that sometimes.
The whole universe would go dark. All the stars
Yeah.
would go dark
Yeah.
because this constant, this way that it is, would be
Hmm.
different. And it would just be slightly different. 1 part in 700. He moves on and says, if the electromagnetic force were slightly stronger or weaker, life in the universe would be impossible. Let's see here. We talked earlier about the strong nuclear force. In other words, the amount that the neutrons and protons are attracted to the nucleus of the atom. There's a certain constant, there's a certain amount of attraction there. And so he says, if we decreased it by 50%, which is tiny, 1 part in 10,000 billion, 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 compared to the total range of how big or small it could be, how strong or weak it could be. He says, since like charges repel, if it would be too weak to prevent the repulsive force between the positively charged protons and an atomic nuclei from tearing apart all atoms except hydrogen. So if that force that holds it together were weaker, all of the protons would sling out of orbit on all but the lightest atoms like helium.
Okay.
So that would be a bad thing because then
That
we
sounds
need
bad.
atoms put together to make life, to make dirt, to make rocks, to make everything. And so if you don't have anything but helium gas, there is no Earth. There are no planetary bodies
And
for life to be
everybody
on.
talks really weird. I think
There's
for some
no
reason.
talking.
Oh, sorry.
There's no talking. Well, my
Which,
house would be quieter.
by the way, Dollar Tree's out of helium. So for those of you that were hoping to do some helium inhaling and talking funny, no dice, no dice this graduation. So I think too though, right? It goes back to just like what we were just talking about. It if you could imagine before there was math and science and all the things that we understand now, that had to have, I mean, technically, in my mind, that would have need to have somehow been figured out in order for it to work. I don't think, you because if that was the case, uh, and it all evolved, then as things continued to evolve and change, we would slowly, and I don't know, depending on how old you think, the human race is, I would think that over the millions of years or whatever, if that's your thinking, that the universe or the environment or the atmosphere, whatever, would have changed significantly enough by now that we also would either have uh, needed to make some pretty catastrophic changes in the physiology of the human being or other living things, as well as just the way the world is, right? So, um, I mean, we can go back however far that they seem to be able to find information through the rocks and all kinds of. I saw a very interesting documentary on the Grand Canyon, and that was, uh, you know, I've never been to the Grand Canyon, so I was like, wow, that's pretty cool, and it was interesting to see because they were seeing stuff that they did not expect to find there, because of course we assume it looks like it does now, the way that it's been in recorded history, and they can clearly see through the rocks and everything else that hey, look, there's a bug, that they can clearly see that it wasn't always that way. They're finding fossils of things that would have only occurred in like the sea, or they
Right.
can't explain why it's there, and I think that's again, evolution is fine, and if you're evolving over millions and millions of years, then the atmosphere that created the evolutionary changes that needed to happen would continue as well. And I don't know that we see it quite as, I mean, I granted none of us have lived a million years, so we wouldn't be able to say, well, back when I was a kid there's a lot more of that oxygen. So
Maybe that's our problem.
I think that's what
No,
it
but
is.
the cool thing is that, like this, we're talking about this strong strong nuclear force.
Hmm.
If that wasn't a constant, if it was like sliding stronger or weaker, you'd have the universe disintegrating or becoming a super clump of matter again.
Right. Well,
So either way, it's bad.
you ever think about it like this too? Think about just science in general, right? Everything, well, I don't want to say everything, but a lot of things in science are literally just smaller experiments of something that already exists. For example, the atomic bomb. I hate to use that one as an example, but that's an example. But, once you had that figured out and you got that not from, oh, somebody didn't just happen upon that. That was something that they could see being caught, happening in the world of physics, science, whatever you want to call it. And so that was just replicated, obviously on a different scale, but that's where the idea came from. Like just like lasers and anything else. I mean, once you could harness these things that were already occurring in nature, right? Then that's where the ideas came from. It wasn't like somebody invented the atomic bomb, and then afterwards we figured out, oh yeah, there's also this thing out here in the world that does that. It's the chicken and the egg, right? It came first.
Yeah, had to.
Yeah.
All right. So let's go back to our biodome illustration.
Yes.
Lee asks, um, for
Yes.
yeah, sorry, there's good stuff, but we don't
Oh,
have
I
time
thought
for
I thought
everything.
I oh
So
I thought we were going to be like on a cliffhanger. Like I had to guess what he was asking.
he says he needs a way to visualize the implications of these increasingly abstract concepts. I don't know
Yeah.
if we've been feeling the same thing. Like these are things that I don't deal with on a normal basis, on a
Yeah.
daily
Right.
basis.
Right.
So he says, okay, go back to the Martian biosphere.
Okay.
Set aside the issue of how the biosphere got there in the first place. We don't care. We're going to ignore
Okay.
that.
All right.
But when you found it, there were 12 dials that controlled the conditions inside the dome.
Okay.
And each dial has an incredibly huge range of possibilities. It can be way, way up or way low down.
Okay.
And so he says, when you departed, you left the dials at random, and as a result, no life was possible. Everything in the biodome died. Then you come back a year later.
Uh-huh.
When you look at the dials, you're amazed to find that each one of them has been carefully calibrated to just the right setting so that life is flourishing in the dome once again. 12 dials, 12 different factors, all optimally set.
Okay.
You know what the headline in the newspaper would be the next day? Extraterrestrial life exists. Right?
Yeah.
Somebody came and put the dials back
Somebody
in the right
dialed
position.
it. Yeah. What was Elon Musk?
Or the scientist he hired or something. Yeah.
Right. It
And
was
it's like
Spock.
in just the exact right position.
Right.
All right.
I mean, and anybody out there that's ever messed with just something as simple as like, well, I say simple, but like welding, you know, you got to have everything just right. You got to have the gas just right. You got to have everything just right. And if you don't, then it's, well, I mean, you kind of will weld, but it's not
Right.
optimal, you know,
and it
and
might
it's
not hold together over
and it's not
time.
going to hold together. That was my point. So I think
Yep.
that that's the other thing that people often, I mean, we take a lot of stuff for granted, right? We take for granted that we're going to breathe in enough oxygen every breath we take to sustain their cells and everything else, and we're going to exhale just enough CO2 to, you know, we're all of those things, and it works perfectly. And you know, and we're designed for it to work perfectly. So,
you know, and that's a good point. On welding, you have 2 dials.
Yep.
And with this,
and believe me, I can
talking,
screw that up really well with only 2 dials.
His example is 12 dials.
Yeah.
You could have up to 30 dials, according to what we read earlier.
Right.
And so we are talking about each one of them has to be incredibly precise.
Yeah.
But not just one of them. They all have to be incredibly precise. They all have to be right all at the same time for
And
life to exist. And all the time. They can't change,
Right.
can't vary. Yeah.
Right. Like oxygen's like, I'm just feeling tired today, guys. I'm gonna just dial it back. You know.
So the last thing we have time for, unfortunately, because there's lots more good stuff. But hey, if you want more good stuff, invest in Lee Strobel's The Case for a Creator. Get the book. It's got lots more in it.
It is a good book.
All right. And of course, like we've mentioned, he has several. He has The Case for Christ, The Case for Faith, and
Case for
lots
Heaven.
of proofs.
Yeah.
Okay.
Case for Miracles. Yeah, he's got.
Haven't even seen those.
I know. Yeah, he's got quite a few.
So if you want proof, if you want evidence, a great series to get into.
Okay. It really is. I think it's also a great series to get into if you're just curious as to, you know, I never felt like from any of his books he's trying to change my mind. I just thought he did a really good job of just letting me sit there and mull it over. I wasn't an easy sale. I think you know that. So it took a while, but that book was a very good one for me because the first hurdle was, is there even a God? You know, and so that was a big deal. That's a hard hurdle. It really is. And that book helped me. I mean, it took a while, you know, I read it and then I had to have the 2 brain cells roll around for a while and hit each other, but
yeah. And but that's normal. Everybody has to kind of let it soak in for a while.
Right.
Okay, let's see here. Oxford physicist Roger Penrose said one parameter of the fine-tuning of the universe, the original phase space volume, required fine-tuning to an accuracy of 1 part in 10 billion multiplied by itself 123 times. It'd be 10 billion times 10 billion, 123 times.
Yeah, I can't do that math.
Okay. This showed, he said, the precision needed to set the universe on its course. All right. As long as we're talking about probabilities, then theoretically, you can't rule out the possibility, however remote, that this could occur by chance. That's random time and chance.
Mhm,
That's the
mhm,
argument, right? It's like, well, eventually, given enough gazillion years,
mhm.
it could happen, even
Well,
if
it's
it's
just like
extremely unlikely.
given enough gazillion dollars, I can eventually win the lottery. So if any of you would like to help me with this science experiment, feel free to send me $1. Trust me, I'll scratch away until I can prove that the odds are in my favor.
I was in the gas station and a guy in front of me bought some tickets, dropped $100, and he left the store. And I told the cashier, I just wish I had the money spent on the lottery tickets. He
Yeah,
looked at me. He said, "You would not believe on
yeah,
a on
all the
a
time.
on a mediocre night, on an average night,
Hmm.
we'll do 3 to 5 thousand.
Yeah, yeah,
That's one gas station.
I know. And
Whoa!
that's, and I mean, I am very happy for the people that do win, and I know there are people
Right?
that do win. But let's all think about it, and let's put this in perspective, right? While we're talking about everything needing to be just perfect. Uh, what is it? I think Powerball or whatever. I think it's like, I don't remember if it's 5 numbers in a Powerball or 6 numbers in a Powerball. I don't remember. Whatever it is, it's a lot of odds. It's a long shot, right?
Right?
And
Right?
I
A little
mean,
bit shy of 10 billion times 10 billion, 127 times.
and if we
That's a
told if
lot more digits.
right, but if we told somebody that was your odds of winning the lottery, they'd be like, "Yeah, I ain't playing," you know, because
I,
yeah, it's just I don't know how else to describe it. But if we know how long shot the odds are for something like that, just imagine taking whatever you said, billions times billions.
right. All right. Let's see here. What if I bet you $1,000 I could flip a coin and get heads 50 times in a row? And then what
Well,
if I did it? What would you think?
I think you were cheating.
Right? That's the only logical explanation.
Right? Yeah.
And that's so far below the probability of everything being
Hmm.
right for the universe that we've been talking about,
Right.
that being balanced on a knife edge,
And that's just
as
two options too. That's just heads or
right,
tails.
right, 50 times. Yeah. Okay. Um, what about if there were you'll dig this, Susie.
Okay, I'm digging.
In the court case, the
Yes.
defendant's fingerprints were found on the gun.
Oh.
Maybe the defendant shot the gun and is guilty. Maybe the correct molecules aligned just right in the shape of his fingerprints
Mhm.
accidentally.
Or it could have been a koala bear, because just so you know that scientifically koala bears and humans have very similar fingerprints. But then the odds of that being a koala bear that had the same type of fingerprint that that person had would be very slim.
Right. We're talking about like a similarity in the
Yeah.
type of fingerprint,
Yeah.
not the exact print
Right. Yeah.
of the exact type.
Yeah, that's
What
going
do
to
you
be some
think?
pretty
Guilty or innocent?
that's going
Is
to
this
be
guy
some
innocent? He's probably
mm,
just innocent.
I
It's
would
a time and chance.
I would probably need to see some other evidence. You know me. But yeah, that doesn't look well. That does not look good for them.
All right.
Mm-mm.
All right. Men have been hung for less. All right. So, really, when you start putting all this together, you have all of these things that have to be just right. They have to be dialed into a crazy accuracy. And it's not just one thing, like you said earlier, it's so many things.
Yeah.
It begins to just really be nonsensical to think that
Mm.
perhaps all these things are just right on accident.
Yeah, and then if that's the case, then how quickly, if it's that, if that's how it happens, then how quickly would it destabilize? Given enough time, what's stopping it from staying constant,
Right.
as we know it? I don't recall here, seeing any history books that are like, well, today, we got a low oxygen day, and then maybe it's like, today it looks like all the trees died, but maybe they'll be back next week. It just, I mean, like if there's a fire or something that can explain it, but it's constant. It doesn't change.
Right. And that really points to super intelligence, putting these things in place and even holding them in place, making sure that they are constants instead of changing. And so there's an intelligence involved. There's also an immense amount of power involved in making these things to be the way they are. So
Yeah.
intelligent design is strongly, strongly, strongly to the power of 10 billion times 10 billion, 127 times indicated here.
Yeah, better than I was going to look and see if I had a lotto ticket. Let's see what this one was. Let's see if I won anything. I won $2. I won $2. But this is also from Christmas. I think it was a Christmas gift. So I really appreciate whoever thought of me and got me a $2 lottery scratcher.
Cool.
So, but I could have won 25,000. Just so you know, the odds of that I think are listed here somewhere, and they're pretty bad. So yeah, the odds of winning. This is great. The odds of winning just $2. So you have to remember, there's probably a lot of $2 prizes out there. Even that is 1 in 438. So
that seems like almost a certainty compared to the odds we're talking about.
Yeah, exactly. Yep.
Wow.
Yep.
So that'll wrap it up for this episode of Church Hurdles. And we've been talking about the extremely delicate balance of the universe, everything having to be in just the right proportions, and there's just too much to talk about in 1 hour. So get the book, read the book. If you sweet talk Susie, she'll even facilitate you getting the book. I don't know. So
yeah, we do have an arrangement with Strobel to provide the books at a discount. So also I believe next week, right?
That's
we're
cool.
out. Yeah, we're out. We are not.
We will be out next week, right?
Yeah. So, and for those of you, so we won't see you until the end of the month. So do have a safe Memorial Day weekend. And because we'll be coming to you. Let's see, I guess it'd be the last day of the month, the 31st. So that'll
that sounds right. Yeah.
Yep. All right.